Hi friends, it's Kamal and you're watching Maths by Jajoria. Please don't forget to subscribe my channel. In this video, I will explain the graphs and transformation, mainly for cubic graphs. Now, before I proceed with this, you need to have a prior knowledge on quadratic equations. So factorizing the quadratic equation and graphs for the linear or quadratic equations by complete the table of for the values for the functions, so like x and y. So these are the prior knowledge you must have before we proceed with this cubic graph. Also, it will be helpful if you know how to solve a pair of simultaneous equation. Now, I have covered this in my previous videos, so those who haven't watched that, please do so. The links for all of these, I will have that in the description box. Okay, so let's proceed with this now. Cubic graphs. So this is a graphs and transformation. A cubic graph has the form. Okay, so this is the form. Yeah, ax cubed plus bx squared plus cx plus d, where a, b, c, and d are the real numbers. And always remember that the a is a non-zero value. Okay, so a is non-zero. Now, before I proceed with the graphs, just to explain some of the graphs, how it actually will look like when we solve that equations. The graphs of the cubic function can take several different forms depending on the exact nature of the function. Okay, so this is what we will discuss. Now, these two type of graphs, you will get, okay, so you can have either this touches here 0, or probably not really touches the 0 but just swinging like this. For these two function, your a, which is here, yeah, a is positive, so you will get these two functions when a is positive. Now you probably know what these two functions would be. Yes, these two functions when a is negative. Okay, now if the p is a root of the function fx, then the graph of y equal to fx touches or crosses the x-axis at the point p and q. P is 0. Okay, so without wasting a time, let's go straight to the question. Okay, so in here I have y equal to x minus 2 and minus x and 1 plus x. Okay, so I have this, and we have to draw now a graph. So basically you see here it is a cubic graph, because if you once you open this, you will get an equation something like this. But however, because this has been given to us, so we will just work with that. Okay, now in this one, the first what we will do, we'll put y equal to 0. So what we'll do, we'll put y equal to 0, sorry, and we will solve, and this is to solve for x. Okay, so we need to solve x. So let's do this: 0, x minus 2. Okay, So with this, you can write x minus 2 to 0, and you got 1 minus x that is equal to 0, and 1 plus x equal to 0. Okay. So what we'll get here, x equal to 2 here, and then x equal to 1 here, and you got x equal to minus 1. Okay, so let me just these are the coordinates we got now. So the curve crosses the x-axis. Okay, so let's write down here. So the curve crosses the x-axis at, so x is 2 and y 0, 1, 0, and minus 1 and 0. Okay, right. So let's make a graph first. Okay, that will help you to understand, and then we can get the other coordinates as well. Okay. So let's do this one. So what we can do, we can just write for here. Okay. No longer. Okay. So, so this is what you got here. So let's say that's a 0. Okay. And just presume this is here minus 1. And you got here 1 and 2. Okay. This is your x-axis. That's your y-axis. So the curve crosses the x-axis at 2. So your y is 0. Okay. So because we had 0 here, y is 0. So you got 2 and 0. So here we got point here, and then you got point here, point here. Okay. So 2 and 0, 1, 0, and then minus 1 and 0. So these are the one. Okay. So it will cross like this. Okay. Cross from there. Okay. Now, so you know these 3 points here. Okay. So we'll come back to that. If you want, I can just write down here as well. So that is your 2 and 0, and then you got here 0, and you got here 1 minus 1 and 0. Okay. So you see your graph will probably go like this. Okay. So obviously it hasn't finished that. We still have to work on this. So the next step now. So the next step will be to find the value of the y when x is 0. So this is here we done y equal to 0. Now in this equation, okay, so let's have this equation now again. Okay, so now x is 0. Okay, so when x is 0, so when x equal to 0. Okay, this is we got now. So we got minus 2 multiply 1 and then multiply 1. Okay, this one we got here. So with that we got -2. So when x is 0, y is -2, right? So y is so what you got now? So the curve crosses the y-axis at just gonna write here, curve crosses the y-axis at 0 and -2. Okay, so your 0 and -2 would be, let's say, the 1. Okay, so let's say it's 2. So that's your -2. Okay, so this is your -2. Okay, so that coordinate that is your 0 and -2. All right, so if I join this one, so I will get something like this here, and from here this. Okay, now it's not really fully completed. I will explain to you why. Okay, you have got these coordinates. However, now if I say to you that what will happen if I say to you that check what happens to y for large positive and the negative values of x. Okay, so which means that what I'm saying is that if we make the x value large positive and the large negative values, so what will happen? Okay, so I'm just going to give you one of the calculation on that one. Okay. So with this one, x with the large positive and large negative values. So let's go with the same thing we do here. But let's presume that when x is equal to, let's say, 10. Okay, just presume that. Okay, so let's see what value it would be. Okay, so with the y you got here, so that's the equation here. Yeah, so the 10 -2. Okay, and then 1 minus 10, and then you got 1 plus 10. Okay, that's from the equation. Okay, so that will give you, okay, so you got 8, then you got multiply minus 9, then you got multiply 11. Yeah, so that will come to minus 792. So your y value would be in negative 792. Okay, so you see, when you have a large value, I mean, this wasn't really a large enough. It was just x equal to 10. Okay, with that equation we got in. You see what you got, the y value is really large as well, so minus 792. So in that case, you can see that if I may say that if the x is approaching to infinity, then your y will also approach to your negative infinity. Okay, so obviously in exam you won't really have minus 792, so we can just say that's infinity sign. Okay, so with that you can say that you can just go like this. Yeah, you got it? Now if you say that your x value that is minus, okay, and you can do yourself as well, you can have any number, okay, and just substitute the value in this equation. However, the x should be minus. Then you will see that if your x approaches to the minus like infinity sign, then your y would be, sorry, y will be positive. So if it's negative, if your x is negative, then it would be like positive. So the large value, that would be positive. So I'm sure you can do that. Just use that equation and insert that one. So in that case, you will see the graph will go like this. Okay. So like you can say that because the number is large, so it's going like infinite number, infinite number this side as well. So this is more or less. The one thing I would like to say to you in this equation, okay, that the x cubed term in the expanding function would be like, let me just write down here, okay, for you. So I would like to say to you that, you know, the x cubed term, okay, in the expanded function, okay, so in the expanded function would be, okay, so I just write down for you, so the curve has the negative. So also because you have this, so the curve has a negative x cube coefficient. Okay, so just remember that as well. I can write down there. If that is that, so what will happen? So the curve has a negative x cube coefficient. So just remember that also. Okay, I hope it's clear, that one. All right. So we're just going to go with the one more example. Okay. And you also see here your graph, the way you got this. Okay. When we compare from these two function. Okay. A is for positive, and this function is two function where a is negative, and this function type of graph for these two function where a is positive. Okay, now let's go with the one more example. Okay, and in this example we'll say y equal to x cube minus 2x square, sorry, minus 3x. Okay, so before we proceed with this, before we need, what we need to do, we need to first factorize this. Okay, so because without that we can't do that. As again said that anything on factorization, or I have previously told you on factorization of these quadratic expressions, and I have discussed this in my previous videos, so please watch that, and the link in the description box anyway. Okay, right, for that we can say, if I take x out, okay, so that will give us x squared minus 2x minus 3. Okay, and then we can factorize this, right? If you want, I can do it here. Okay, just quickly for you. Okay, so I think we should do this one. Okay, so as you know that the product of the two numbers, that should be minus 3, and sum of that, when you add that, that should be minus 2. So what that number would be, so we can say minus 3 multiply 1, so minus 3. Okay, and then you can say minus 3 plus 1 is equal to minus 2, right? And as you know that once we know this, so let's factorize this. Okay, so let's check again. Oh yes, so we took x out, so you got x minus 3, then you got 1 here, then x minus 3, so x minus 3, x minus 3, so we know that it's the same. So these are the so we got this factorize. Now just write down here these ones here. Okay, so what will be then? Y will be your x x minus 3 and x plus 1. Okay, doesn't matter which way you write, you can either write x minus 3 or x plus 1, so that doesn't make any difference. Okay, so we factorize that one. Now once we did this, then again same thing, like we say, okay, y equal to 0, so 0 equal to, okay, x minus 3 and your x plus 1. Okay, so you got here x equal to 0, yeah, x equal to 3, and you got x equal to minus 1. You got it? Same thing, like, you know, you do x equal to 0, then you go x minus 3 equal to 0, then x plus. I can write down if you want, because we will get 3. You got x equal to 0, then you got x minus 3 equal to 0, and then you also got x plus 1 equal to 0. And this is what we got here, yeah? Okay? All right. Once we got this, so you know that you got the coordinate now. So the curve crosses the x-axis. So the curve crosses the x-axis at, so you know your first one is x is 0, so y is 0 as well. So you got here 0 and 0. Okay, then you got 3 and 0, and minus 1 and 0. Okay, so let's do this. Okay, so at least you know these 3 points, you got this here. Okay, so this is your x, and that's your y. Okay, so that's your minus 1, is 0 and this 0, let's say 1, 2, and that's your 3. So you got 1 here, 0.0 and 0. Then you got 3 and 0. Okay. And then you got your -1, 0. So you got here like this. So you know that somehow your graph will just go like this from here. Yeah, so you know, just write something like this. Now same thing again, I will say to you that you can check what happened to the y for the large positive and the negative value of x. So same thing you will do here. Okay, what we have done previously. Let's go back to that. Remember here, when we said that x is 0 and you got the y value. Okay, so I'll leave that with you. You can, I'm pretty sure you can get that coordinate by substituting the value. Okay, so you can say, okay, x is 0 here, so then you see that your y was 0 as well. However, this is the cubic curve with the positive coefficient of x cube and 3 distinct roots. So you obviously have these 3 distinct roots. So I'm pretty sure you can do that. So check what happened to y for large positive and negative values of x. So, okay. However, I can just write down for you here that x approaches infinity, then your y will be also, but this time positive and positive. Okay. And if your x is negative, then your y would also be negative. Okay, so it would be different than your previous one. Okay, however, you'll find now if you have x is your infinite, then your y is infinite as well. So you see that your curve will be like this. Okay, so let me just write down here as well. So this is a cubic curve. So that's the cubic curve with a positive coefficient of x cube and 3 distinct roots. Okay, so positive, this type of curve, and if I show you here as well, when I was talking about the graphs of cubic function, can take several different forms depending on the exact nature of the function. So you see, you got these two functions when a is positive. Okay, so this is what you got here for this. Right. So I hope it's clear to you. Okay, and as I also said that if you're not sure about your what I have already discussed in my previous videos about factorization, you know, on quadratic equations and graphs of the linear equations or quadratic equations by using the compare tables and simultaneous equations and all that is in the all the links in the description box. So please watch that if that is not clear to you. And do me a favor, if you find this video informative, please like and subscribe this video. Okay, I always say that when you like and subscribe, it just motivates me to make more videos. So please do so, and be sure to click that like button and drop your comments if you have any. questions, and I will do my best to reply back to you. Thank you.